Hi, this is Sung. I'm your online maths mentor, and we've been going through now basically the chapter on permutations and combinations. Again, in normal vernacular, it's all about arrangements and selections, yes? And basically we're working out counting principles or ways to count different arrangements and selections given a variable set of conditions that we need to meet. Now, we've been going through permutations, which is basically arrangements, and we came up with a general formula or a general method for finding the total number of arrangements under a certain set of conditions. Now, the set of conditions is this. You've got n elements within a whole or a complete group of which we're choosing r, okay, the number r, elements out of those n elements. All right, so in the last example we talked about the 12 horses and choosing the 3 winners. So n would be 12 horses, and r would be 3, choosing the 3 winners in the order that we want them to be in. And the number of arrangements where you can get 3 winners, or sorry, first, second and third place from 12 horses would be n, which is 12 factorial over 12 minus 3, which is 9 factorial, right? So that's your general formula for working out the total number of arrangements. Now, it's not always going to be that simple, okay? It's not always going to be that simple where it's just a matter of plugging the numbers into a formula, right? And remember how I said in previous episodes that things are going to get a little bit interesting, right? Which is really just a euphemism for frustrating, because things can get frustrating. Here are some of the common variations, right, that make these sort of questions a little bit more frustrating than just simply plugging the numbers into a formula. All right, so here are some common variations. So, and we'll go through, I'll spend an episode going through each of these variations. The first one is restrictions, right? And this episode will go through what restrictions are. The second type of variation is where you have groups within groups, okay? So you have one group and then you have you have like a little group, all right? Within, which you treat like one element within a bigger group. So for example, you might have a situation where one person has to sit next to another person in a line, okay, or in a row of seats. And the 2 people sitting next to each other have to be there, right? You treat as one element, right? And then you've got to work out all the different arrangements of that little group as part of all the different arrangements of everyone in the bigger group. All right, so yeah, things will get clearer when we go through that example. Anyway, so you've got groups within groups. Another one is identical elements. So this might be a typical example of this. It might be basically where you're trying to work out the number of arrangements of a certain combination of letters, right? But you might have one letter or another letter occurring more than once, right? So for example, a word might be the word look, right? Look, you've got 2 O's, right? They're 2 identical elements. And so you can't just treat it as 4 choose whatever, right? 4 choose 4, 4 choose 2 or whatever. You've got to account for the fact that you've got 2 identical O's. You've got 2 O's sit together. The other type of common variation is basically instead of putting the arrangements in a line, right? You're putting the arrangements in a circle, right? And there is a way to do that. There is the general rule for how to do that, and then you've got the variations for that within the circle. So you've got, for example, alternation, where you've got boy, girl, boy, girl. You've got groups within groups where 2 people have to sit next to each other in a circle or whatever. And then you've got another example, which is beads on a bracelet, in which you've got to take into account the fact that the clockwise direction is the same as the anti-clockwise direction and whatnot. So it gets a little bit hectic at this point, but they're your common types of variations. Now, I'm sure there's more, right? This isn't a complete list, but these are some common ones that you'll get in the Extension 1 course, all right? So that is basically an overview of some common variations that you'll get in permutation type problems. Let's go over to the left-hand side and go through basically the first variation here, which is restrictions. Now, let me just explain how this works by going through this particular question. Let's read this question. It says, how many 4-digit numbers greater than 5,000 can be made using the digits 0 to 9 without repetitions? All right, so you're using the digits from 0 to 9. At most, you're using them once, right? So you can't use the same digit twice, but we want the number, the 4-digit number, to be greater than 5,000. In other words, we don't want to use the numbers that are less than 5,000. Okay, so we've got to restrict the number of arrangements that we've got to the ones that are above 5,000. Okay, so let's work out how to do it. Okay, cool. So let's choose. Well, we've got 4 digits that we can that we need to create. So in other words, we've got 4 positions, 1, 2, 3, 4, yes? Okay, now ordinarily, if you have, how many digits are there from 0 to 9? You've got 10 digits, and we're choosing these 4 positions, right? So basically our answer ordinarily, if we weren't restricted by the 5,000, would be 10p4. Does that make sense? Ordinarily that would be our answer. Okay, but it's not going to be our answer in this particular case. Okay, so I've got here that 10p4 is not our answer. It's not the answer we want because we've got some restrictions here, but it is the general answer if we didn't have any restrictions, right? So that would generally be our answer if we didn't have restrictions, right? So how do we do this? Well, the first thing we need to work out is that in order for this to be over 5,000, we want this position here to be 6 or greater. Does that make sense? This position here is going to be greater than 6. Yes? Greater than or equal to 6. Let me just say greater than or equal to 6. In fact, it'll also be greater than or equal to 5. Right? Because as long as you've got 5 there, all right, all these other numbers are going to be, they can't all be 0. Okay, so they're all going to be other numbers which will make which would make the total answer greater than 5,000. Yes. So how many numbers or how many choices or how many digits can we put in position 1? Well, we can put 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5. So we can put 5 choices in position 1. Yes. How many choices then are there left to put in position 2? Right. Well, in position 2 now we've got 1 less number than the 10 that we have to choose from. Okay. Now there are 10 choices. How many digits are there from 0 to 9? There are actually 10. You can count them on your finger. Okay. So there's going to be 1 less than 10, which is 9. And then you'll have 1 less than 9, which is 8. And you'll have 1 less than 8, which is 7. Okay. So basically your answer will be, with restriction, so with restriction our answer will be 5 times 9 times 8 times 7. Got it? All right. And another way of writing this is that it'll be 5 times 9p3. Okay. So instead of being 10p4, it'll be 9p3. And the reason why we get that is because we'll have this 5, you can't do anything about this 5, right? But then you'll have 9 digits left over, of which we need to fill 3 positions. Yeah, so it's 5 times 9p3. And you can work that out on your calculator. It'll give you a specific answer, and that will be the answer that we want. All right, let me quickly work it out on our calculator, and then I'll tell you what the answer is compared to what we have here. All right, was that without restriction, so in other words, if we weren't restricted by the fact that the number had to be over 5,000, we would have 5,040 possible 4-digit numbers that we could create. However, because we're only interested in the numbers or the 4-digit numbers that are greater than 5,000, with that restriction, we will only have 2,520. Got it? All right, so that is like a simple example of one, or the first variation of the permutation principle. Okay, thank you very much for watching. In the next episode, we'll go through the very second example of a common variation. Like I said again, thank you very much for watching.